talk about methane. This powerful greenhouse gas has a warming potential up to 34 times greater than that of carbon dioxide. It traps heat in our atmosphere and acts to enable the effects of global warming that we all hear so much about. Aside from human-induced emissions, methane and the greenhouse effect it enables are a naturally occurring mechanism in the Earth's thermostat. It acts to keep our planet the Goldilocks planet that we all know and love. Not too hot, not too cold, just right. I say all this to establish the main characters of my research as sympathetic ones before I introduce them to you. So, who are those main characters? Microbes. These guys, specifically methanogenic archaea, or methanogens, produce methane in a variety of locations, from ocean seeps to cow guts, as you can see with my underwater cows. Anywhere anaerobic conditions persist, they create a methane cycle with their counterpart, methane-consuming bacteria, or methanotrophs. These guys, the Pac-Man. And freshwater ecosystems are a substantial contributor to global methane budgets. So my research is aiming to identify the microbes that contribute to the methane cycle in the Arctic lakes of the Mackenzie River Delta. This delta has over 40,000 lakes and is a highly biologically productive ecosystem. This summer, I will fly to Inuvik in the Northwest Territories, a town that is surrounded by the delta and is about a 3-hour drive south of the Arctic Ocean. While I'm there, I will take samples from a representative set of lakes of environmental characteristics and methane concentrations. In order to identify the tiny microbes present in those samples, I will use PCR. This is the same PCR that we all now know from COVID tests. I will amplify the genes of interest, and I will see if the lakes have methanogens or methanotrophs. This will tell me if they're there, but it will not tell me the specific species. In order to do that, I will have my samples sequenced to obtain the genetic codes. I can compare these codes to known codes of methane producers and consumers in a database, like looking up numbers in a phone book, in order to determine who is present. At this point, I will have a species composition list that I can compare to lake characteristics such as presence of plants or water temperature, and I will be able to establish a baseline that we can refer to as the climate changes. Because as the species composition of these guys change, methane production will change, and there will be potential impacts on climate change, as well as changing our planet away from the Goldilocks planet. Thank you so much for listening. I hope you learned something new.